Okay, so I thought it'd probably be best if we start with a quick introduction. So my name is Philipp. I'm one of the founders of Violet. We're building an identity platform, which I'm going to be talking more about later in my talk. But for this panel, look at me or viewed me as a potential developer who's going to use zero-knowledge applications. That's, I think, the center of my questions. But why don't you guys quickly introduce yourself, the zero-knowledge stuff that you're working on, and then we can take it from there.
Cool. Great. I'm Brandon. I'm a founding engineer at O1 Labs, and we incubated Mina protocol. So I've been working on it for 5 years almost. So Mina protocol, I'll just give like the 10-second for people that don't know. So Mina is the world's lightest blockchain. Essentially, the blockchain is replaced with a zero-knowledge proof, a recursive zero-knowledge proof. And we are working really hard to add smart contracts on Mina. So Mina's on mainnet right now without smart contracts. Smart contracts are in testnet. And on Mina, we call them ZK apps. You build smart contracts entirely that run entirely off-chain and create zero-knowledge proofs. And the proof system is powerful enough to roll them up into the main Mina blockchain proof. So I'm sure we'll talk a lot more about it.
Very cool. I'm Calum. I'm from Spacetime, and we're building a Web3 decentralized database. And we're using ZK rollup technology to basically roll up the state. So we'll basically have a layer 1 blockchain where we post the hash of the state of the database, and then all transaction rights are basically rolled up, and we shard across. We can shard across thousands of nodes. And so yeah, that's really how we. So if you think about a ZK rollup today, it's usually for financial transactions, and there's kind of cutting edge stuff for rollups on smart contracts, but we're kind of rolling up structured index data, and that's what makes us different. So you can think of us would be a drop-in replacement for Firestore, Firebase database, but decentralized.
Awesome. So you guys are the experts. I thought maybe a good way to get us started was that zero knowledge is one of these technologies, right? A lot of, most people probably in this room have heard of it. They probably have some perception of it. But if I'm a developer, how do I learn about zero knowledge, and what can I actually build with it today?
Yeah. The question is like, why are you learning about it? And if you're learning about it because you want to build something using privacy or scalability or any of these interesting features, then you don't have to dig into the crazy the math behind how everything works. Unfortunately, there's not many resources that don't do that, and there's not many platforms that allow you to learn about or allow you to build zero-knowledge applications without doing that. And that's why, for Mina, we are building one of those platforms where we want it to be really easy. So one, if that is your category, then ZK apps on Mina and Snarky.js is our framework for building them. It's all in TypeScript. It should be really familiar to Web 2 developers. And we've done as much as we can to kind of enable people to get started without going so deep. And if you do want to go deep, then there's an entirely other set of resources that you should look at. I found there's a blog post series by Vitalik from 2016. Have you seen it? Yeah. Yeah. That you can follow along with a pencil and paper and do. I think it's a Groth 16 snark, but it's it's just math, and it took me 10 hours or something to work through it, and but afterwards I understood how snarks work, at least in that sense. And anyway, I don't want to keep talking forever, but there's these kind of two different paths, so you have to pick one and then decide.
Yeah, there's also a really good website. I think it's called ZK Science. If you Google it, I think you'll find it. And it has a bunch of other links to that paper, that blog post. So that's really good. I think from a high level, if you're a developer, like why would you want to use this technology? So it allows you to basically run a function and then prove that you ran that function correctly. So I could tell you that like I added these two numbers together and like I could prove that I did that correctly without you having to rerun the transaction yourself. So pretty much all of the scaling problems we see with existing things is because every node in a blockchain today has to rerun the same transactions, has to hold the same state. And that's just not going to scale like long term. So I like to think of like ZK snarks are basically, or everything that's not a ZK snark is basically in place because ZK snarks haven't made it there yet. So like if it's not there now, it will be in 5 to 10 years. And I think like the last 3 years has seen incredible, like probably 100x in the last 3 or 4 years in terms of snark, how fast snarks are to run. So there's still this like idea in people's heads like snarks are super, super slow. And they can be super, super slow. But they don't have to be. And there are ways around tying them to your use case, which is if you're going to go more into the research side of things, which is like heavy kind of customization. Sorry, am I going on too long?
No, please.
But yeah, there's kind of, you can do that, or you can use a platform like Mina, which I think is a great platform, by the way, which kind of takes away and abstracts some of that away for you. But you know, in terms of the future of like where computation is going, like imagine a future where every client device is doing computation and then posting the results, right? So no longer do you have serverless centralized. You don't even need to talk about that, right? Like, because every client's running it on their own device and just posting the result. And we've never been able to do that. Like that's something completely new, which will transform everything.
And you know, and I should like, I mean, especially given the talks earlier, there is currently, based on like the current hardware we have, there is a performance trade-off that you make. It is, even though it's 100 times faster than it was before, it's still an order of magnitude or two slower than not using ZK proofs. But for a lot of applications, that's okay. And there's a lot of cool stuff you can do.
I have a dumb question for that. So if I'm a developer and I want to use zero knowledge in whatever use case that I'm building, does that imply that I'm going to need specialized hardware today, in the future?
No. Or sorry. Yes, that's a great question. No, you do not need specialized hardware. There's a couple questions you need to answer, which is where do you want your proofs to be running? And depending on your application, there's different answers that make sense there. If you're just using zero knowledge proofs for scalability, then you can have the proving run in some data center and on some like specialized hardware, and that's okay. And if you build on platforms, ZK scalability platforms, ZK EVMs, this is like what's happening. But if you actually want to take advantage of privacy in your own applications, then you're going to want the proofs to be running on the computers of the users who have the data. So I guess you do not need specialized hardware, and you can even, in many platforms, I'll just talk about Mina's, you can run your prover function in the actual web apps of the dApps. So like computation happens in the browser on the user's machine, and only the proof that computation was run correctly, as Calum said, that's what gets sent to Mina's chain and settles.
Okay.
Sorry, that was long-winded.
No, it's a great answer. I have one more question, and before I ask that question, I just wanted to mention that if people in the audience have questions, then there's this box thing. But the question that I had was, you talked about use cases, right? And I think, at least from being a person that is deeply in crypto, I think sort of like the most prominent ZK use case are rollups today. At least sort of like that's what if I'm a developer sort of exploring Web3, that's the stuff that I read about. What are some, I guess, non-obvious use cases? What is possible? Maybe I guess you're building something a little bit more on the application layer, but maybe you can share some thoughts here.
Yeah, I mean, we're using them for rollups, but I think it goes to what we said before and what you just mentioned, is you can use them in a client to prove data that you have. So let's say, for example, I want to prove my income, right? And so I don't want my income from my bank to be given to someone else. So what I can actually do is the bank can do a proof doesn't say exactly what the number is, but they can prove it's within a range, which is pretty cool. And I think like when we get like soulbound tokens and those kind of the next kind of generation of what NFTs can be, I think that will be really powerful. Like, hey, I could prove that I have a degree, but you don't need to know everything about that degree. You don't need to know where I got it from or what year I am, so you can work out how old I am, and you can kind of discriminate against me because of my age, for example.
May I add? Yeah. So we're working on infrastructure that not only like, yes, your bank can build a ZK proof for you, or you can just bootstrap the TLS certificate that browsers, like modern web browsers and the modern internet is when you're accessing an application, it's already cryptographically signed to be sort of authorized by some source of truth. And like if you're for example, if your bank doesn't support ZK proofs, but there is a Web 2 interface to it, you could just pull that data from Web 2, you bootstrap using the TLS signing that's already there, and then roll that into your ZK proof. And this is something that we're working on Mina. But just to add, like so these kinds of range proofs are like more like the hello world of ZK snarks. But really, some of what I'm about to say are limited by performance right now. But you can do like imagine proving that like my ID, my like driver's license, a representation of the pixels in it, like prove that have a date on it such that I'm older than 21 or something, or like my DNA is sequenced by some 23andMe or whatever, and like I don't want to give my genome to some random startup, but I wouldn't mind giving like a ZK proof that says like my genome doesn't express this particular trait, so give me, I don't know, let me have access to some forum or some other dystopian thing. But I don't know. Healthcare, yeah. I mean, that's also, yeah. It's a little dystopian, but healthcare data, financial data, identity,
Probably the other thing that's not a rollup would be doing computation on the client side, which we already talked about, and being able to push the end state to a server. So if you have, imagine a blockchain running today, you could basically push the end result. This is not necessarily a rollup, but you're just pushing that end value. But as long as you run the snark, like the blockchain will accept that transaction, that state being set. So I think that it's similar to a rollup, but it's not exactly the same as a rollup.
Multiple questions.
Oh, intercept failure. So what is the state of more productized ZK, specifically with identity, and me being able to do something like prove my age without showing my date of birth? And if the state is not impressive, how far along is it? What are the blockers?
Same question.
Okay.
Yeah, this is a great question. I'm going to get in trouble for not knowing like a better answer to this question, because there are people on my team who do. But I would say there are a bunch of companies who are working on this problem, and one of the someone who was planned to be on this panel is working on one of those projects. Yeah, I think right now we're in this space where there are people working on the problem, and there's nothing that's like out of beta or alpha, and all of these teams are still experimenting with, what is the underlying ZK backend that they should use, and we're hoping that a lot of them choose to build on Mina because we think it makes sense, but the sorts of conversations we're having with companies that are working on these things are sort of that's kind of the state of it, I guess.
Yeah, and I think like if you want to, like, there's a software called Circom, which you can use to create a Groth16 snark today using their language, and they actually have a plugin for a bunch of other snarks. There's basically a whole range of different ways of doing snarks, effectively. Groth16 is today the most performant way, but it requires a trusted setup for every different circuit you create, which is kind of annoying. So basically there's a whole bunch of new technologies which is trying to remove this.
Explain trusted setup.
Yeah, so basically, you basically have to come up with a cryptographic key that everyone uses that no one knows. So you basically have these really weird ceremonies where everyone gets together and shares some codes, and there's like been improvements in the way that works, but it's still a bit weird. And and then you have to kind of prove that like. There's the latest ones. There's multi-party, so as long as one honest party is in this like network, it's okay. But if all of them colluded, then they could basically just break it and create a proof for anything. And so obviously, given how difficult that is, you don't really want to do that. And for something like a blockchain, where you want to allow people to upload their own smart contracts, Groth16 was never going to work. So probably the best, like most promising technology, which the community is building around, I would say, is Plonk. So you'll see that a lot if you start researching ZK technology. There's actually a Plonk 2 now, and no doubt soon there'll be a Plonk 3. And there's another technology called recursive snarks, which allows you basically to continue, which is actually what Mina uses, which allows you to continuously build on top of a previous proof. So rather than like recreating a proof every time you have to do something, you can just add to the existing proof and say, oh, I also saw this, or I also saw this, and I also saw this. So if you wanted to, well, maybe you can explain how it does work in Mina.
I can, yeah.
I have a math question.
Yeah.
Is there some like error rate there that just eventually gets reproduced and then you have a very erroneous zero knowledge proof?
No.
Okay.
Isn't that cool? Or, I mean, some cryptographer might be like, yes, it is, but it's just really small.
It's the same as like all cryptography, like, well, not all cryptography, but most cryptography, like theoretically can be broken with quantum computers, because if you have enough compute power, you can do it, but not outside of that.
Yeah, it's like, don't quote me on this, but it's like, in 100,000 years, if all the computers in the world are working together, they could break it. But this is like acceptable because, it's secure enough. Yeah, I will. It might be true. I don't know the state of like gas-efficient snark verifiers for EVM. So it could be the case that Groth16 is still the most efficient in that world, but. The Plonk-based snarks are much, much faster at creating proofs and verifying these days, at least if you do it to the metal.
Yeah, so I think the differentiator is, and this, you can go very deep on this technology, obviously, and there's multiple different components which go into, like, for example, if you're using a ZK rollup, you're basically creating a bunch of hashes which you want to roll up into a single hash, right? You've got Merkle tree, which is a combination of a bunch of hashes. And so creating those hashes and proving out those hashes is obviously the main thing you're doing with a rollup. And Plonk is more efficient at hashing a specific new hash, which has been created just specifically for Plonk, called Poseidon. So if you use that hash, then that's better.
Yes, actually, Poseidon came before Plonk.
Okay.
But yeah, I will. Well, I'm happy to talk about recursion a bit. Or is that...
Maybe go find Brendan to talk about recursion after the talk. Okay. And I know you had a question. If you want to ask it, otherwise I have something else.
Okay, I'll be quick. So you talked about, as you were, doing the math of the Vitalik ZK, that there was like a specific type of snark that you learned how to do. I didn't realize that there were different types of snarks. Would love to know kind of, the range and the breadth of them, and then what are the maybe specific use cases for ones versus others?
Yeah, it basically falls into 3 categories, and it's mostly to do with size. Like, there's basically different characteristics that you might want from a snark. So you would pick the one that is most applicable to your use case. So on the trusted setup side, where you have to do a separate trusted setup for every single piece of code you write, that would be Groth16, which arguably it's the thing that people use as a benchmark for all other snarks. You have
it's the most it's the most battle tested. So some people like that.
yeah,
but
I mean it's what ZK Cache uses today, and that's
it's a bit
in production,
outdated.
and so it's probably the most stable. The other thing that people look for is succinct, how long it takes to create the proof, and then how long it takes to verify the proof. So generally speaking with snarks, it takes a long time to create a proof. Generally with most snarks, it's very quick to verify a proof. So again, depending on your use case and like how much, the longer the proof, the less optimizations that can go into that proof, then the quicker it is to create that proof. So if you've got loads of space, space isn't a problem for you, then go for one of those ones. And if space is a real problem for you, then you need to find one of the other ones. But I'd say look at Plonk, because that's really where the community is building behind.
Yeah, and just to clarify, just to make things more confusing, there isn't like a one, this is the Plonk snark. Plonk is like it's a mechanism for improving it's like one sort of tactic that you use when you construct your snark proof system. So like Mina's proof system is called Kimchi. And we name all of our proof systems after pickled vegetables. So this one's called Kimchi, the new one for ZK apps. And typically proof systems are a grab bag of these particular trade-offs. So like for example, Kimchi, we have infinite recursion, which we need for Mina to work, because the blockchain keeps growing forever. But you also get to use that in your applications as a side effect. It's Plonk-based, so you get that nice benefit from the Plonk. We have no trusted setup, which is nice because you don't have to do the ceremonies, and a couple other things. But I think every project, or many projects that are using ZK snarks, particularly blockchain, like L1s or L2s, they've rolled their own proof system. So they've taken pieces and put them together, and there's a lot of different trade-offs. So I think it's a tall effort to try and like learn about all of them, sadly. But you can learn about these pieces. You can learn about what Plonk is and what the trusted setup versus no trusted setup and the trade-offs. I don't know if that was helpful, but
I think the other thing that's really important, which I think was mentioned earlier, is like you don't need to have it from day one, right? Like just have it on your roadmap and start investigating, like finding the people who you can build in your team to kind of build that technology. Because I think everyone understands that there's only so many cryptographers in the world, and this is a hard.
Yeah. Or have no one on your team doing that, and use tools that are built to be more general purpose. Like,
and that specifically, I wanted to ask. So what is really rate limiting the ZK adoption? Obviously, sort of like the tech seems to be developing, emerging. Still probably a bunch of open questions. But what is really, in your mind, in your words, required for this to have more sort of like broad applicability? Maybe also you can talk about Mina's roadmap in that context.
I mean,
Okay.
I think we're at the stage with this metaphor gets used too much, but like in the 80s with the internet, we didn't know that there was YouTube or Google or Facebook, but you could kind of tell that some people could tell that there was something there. In some ways, we're in that space with blockchain and Web3 and crypto in general. But with ZK, we're really early. There's just there's so few people that know how it works, and there's so few hours put into tools to make it easier. There's so few hours put into learning materials at the deepest technical layer, and then those kind of flow out to be more accessible. And so this is something we already are starting to, and a lot of teams are starting to put more effort into, education, and then also making tools that are really easy to use. This is, please go and try Snarky.js. That's the Mina's framework, and tell us what's hard, and we will try and make it easy.
And also Spacetime, which is what we're doing. Because we're also going to do that. Well, it's actually for a very different use case, so you can use both of them. But if you need a database,
use them together.
Yeah, if you need a database that is verifiable at scale, then that's Spacetime.
Awesome. Any more questions? Oh shit.
Which one? Anyone?
Wherever.
Hey. So as I've tried to look into this, and like several companies are working with ZK, but there's also non-companies working on ZK stuff. And so I wondered if you all would comment on like what kind of gathering places the people working on ZK-powered apps are gathering and sharing good ideas. Where is the commons of zero knowledge that is producing these other opportunities? And like one good one I found is like the NIST newsletters, for example, where certain cryptographic things frequently play out, but there's other ones too, probably. So which ones work for you?
Yeah, there's actually a SNARK conference, which happened in April, I think. And they actually have like a website and a community board where you can just post questions, and everyone's super nice in there. So
what's it called?
I can't remember. I think it's got SNARK in the name. But if you do just Google like SNARK conference, and there'll be like, it's on YouTube, all of the YouTube videos, so watch a bunch of those. Go to ZK Science, that's a great website too, for resources.
Yeah, I have more too. The ZK Zero Knowledge podcast is a great resource, and that organization or community. There's a ZK hack subsection, and it's all ZK. It's a really great group of people. It's neutral as far as like which chain. 0x Park also is like a really good more kind of neutral party, but right now they're very focused on Ethereum.
Great name.
Yeah, right. But yeah, and then the individual projects that are like really invested in ZK all have their own little groups. So like you could join our Discord, and there's a channel to talk. But
the ZK podcast is Anna Rose's podcast.
Yes, Anna Rose is. Yep.
Probably one. I don't know how much time we have. We're down 0, but we can definitely take some more questions, I guess. One more.
One more? That's me. Okay.
Better be good.
I know we're talking about like the developer side, but like when we even talk about the bank example, right? Maybe you're applying for like a lease or something, your proof of funds or whatever. Like that's all great. We can do the ZK proofs for that. That's all great. But like, who's going to accept that? And how are they going to accept that? Like your landlord, or you're applying for a loan, right? Like what does that interface look like? Who's building those interfaces, and who's working on convincing enterprises and other people that when you see a ZK proof, you can actually believe in it?
Yeah, I can
Go for it.
try and take it. I can confidently answer part of that question. I'm so bad with names of companies and people that I can't actually call out the specific teams. But I would say using that stuff for more real world things, like working with houses, there are companies doing that, but they're very early. I think the earlier applications of these kinds of information, these proofs, are, for example, uncollateralized loans. In DeFi, or KYC, anonymous KYC, like proof that I have KYC'd but keep me anonymous. These sorts of things can be like immediately applied to DeFi and other sorts of existing Web3.
I disagree.
Oh, cool.
So I'm
you're moderating.
So I'm on the application side, and Violet is building a product around compliance, on-chain compliance.
Oh, perfect.
And it turns out that for sort of on-chain compliance, it's not. You would still have to have some kind of provenance or persistence over the data that is somewhat centralized, so other people can access and give access to it when it comes to regulators, right?
Perhaps, and you tell me, I could be wrong.
Yeah.
There could be one entity that the government goes to that accesses the data,
Yeah.
and the other like little startups that need the proof
Yes.
that they've been KYC'd.
You could totally
They
do.
can still have anonymized data, right?
You could do it that way,
Okay.
but it would still imply that from a user perspective, from a client perspective, you would have to build a proof to prove that the data that you're proving towards the application is actually still the real data, so you haven't tampered with the data. Which still implies that you would have to, interface someone centralized who's hosting the data.
Yeah, which is why you need a decentralized database. Because if the data is decentralized, then all of the data is on chain. and verifiable, and then you can check the provenance of the person who put it on chain.
Yeah. And
Okay,
then
on-chain people, there are a bunch of people working on this already live and rolling into governments. DIDs, verifiable credentials, are happening today that can be improved and composed with ZKs. Absolutely. In fact, because a lot of those long proof chains. A counterexample is that Australia rolled out a driver's license-based ID system that apparently never bothered to talk to a cryptographer and is trivially hackable. So that's a thing. These two worlds need to talk more because it's yes and generally. There's lots of hard on-chain problems, but like literally this is being adopted. My province, of British Columbia, has long led in identity solutions, and they have a bunch of this stuff running today. So it's already happening, which is good for all of us. And if you need to get to data that's anywhere in the world that isn't tied to one provider, might I introduce you to your friend and mine, IPFS and content addressing. So lots of something we're basically waiting for the limited number of cryptographers to please hand us some ZK libraries. Thanks.
Yes, and we are, on our roadmap is Snarky.js, but you don't need a blockchain attached to it. So that's coming.
okay, thank you guys.
For O1 Labs.
Wonderful. Ladies and gentlemen, the ZK panel.